Students, today we will start with the new NEET topic, gravitation. Okay, in this gravitation lesson, let us start first knowing what is the Newton's law of gravitation and what is the property of gravitational force. Okay, so the Newton's law of gravitation. What is the Newton's law of gravitation? If the 2 point-sized masses m1 and m2, if they are separated by the distance of r, the force of attraction between the two masses is given by the formula capital G m1 m2 upon r square. This is the formula for Newton's law of gravitation. And so capital G here is nothing but what? Universal gravitation constant, whose value is 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. So this is the value for the capital G, universal gravitational constant. Now let us start understanding the properties of gravitational force. Okay, the first property is it is always attractive. Okay, so it is always attractive force. It is always attractive force, and then its direction is always, the direction of this force is along line joining the two centers. Line joining two centers. Okay, and sometimes since the force of attraction is along the line joining the two centers, it is sometimes referred as a central force. It is nothing but what? Central force. So what is the meaning of central force? If the action of the force, if the force of attraction between the two masses, since the force of attraction between the two masses is along the line joining the two centers, it will be called as a central force. In general, the central forces are conservative in nature. What is the meaning of conservative force? So conservative force is nothing but, so between any 2 points in the field, if I shift one point-sized mass through any of the path, then the work done do not depend upon. So here if I say it's a W1, it's a W2 and it's a W3. Let us suppose in this path I have traversed the mass from this point to this point, and this is another path, this is another path. Now the work done do not depend upon the path followed. It depends upon only initial and final points. Since for this path and for this path, initial and final points are same, we can write W1 equal to W2 equal to W3. And this is the nature of the conservative force. And my gravitational force of attraction is basically conservative force. Okay. So here what we understood, Newton's law of gravitation. This is the point-sized masses separated by the distance r, and this is the force of attraction between the masses. Capital G is the universal gravitation constant, and these are the basic properties of gravitational force of attraction. Now, what is the first property? It is always attractive force. And what is the second property? The direction of the force is along the line joining the two centers, and therefore it is called as a central force. Okay, and generally central forces are conservative in nature. So the Newton's law of, the gravitational force of attraction is generally conservative in nature. Okay, now, so this is how we can understand the basic properties of gravitational force, and this is the Newton's law of gravitation. Now, based on this context, let us do two simple problems. Okay, right. So I would like to begin with problem number 1, based on the Newton's law of gravitation. The force of attraction between the two masses. Based on that concept, we are going to see now one problem. Okay. Well, so let us begin here. The problem number 1. So here I will just read the problem, and then I will explain diametrically what is the, with the help of diagram, I will explain you again what is the concept given. Okay. So the question goes like this. 3 identical bodies of mass capital M. So there are the 3 identical mass capital M, and which are located at the vertices of an equilateral triangle of side L. So there are the 3 point-sized mass I told na. These 3 masses are located at the vertices of one equilateral triangle of side L. Okay, na? Okay. So they revolve under the effect of mutual gravitational force in a circular orbit. Then what is the speed of each particle? So if they are moving in a circular path like this, say, okay, na? So here let us suppose they are moving in a circular path like this. Because of the mutual forces of attraction among them, they will let us suppose they are moving in a circular path like this. Then they are asking to find out what is the speed of the each particle. So if I find any one particle speed, that will be same for the remaining two also. And that's what we have to find out here. Now, what we know about the circular path, if one massive particle is moving in a circular path, that must experience some force, and that force must be act as a centripetal force. Am I right? So whenever the F force is acting on the particle to execute that particle in a circular path, then F must be equal to what? mv square upon r. Right or not? Then this will be called as what? Centripetal force. And that centripetal force formula will be mv square by r. From there we can find out what is the speed of the particle. Okay, what is the r here? Radius. What is the v? Velocity or speed. And what is the F here? Centripetal force. Here the centripetal force is provided by whom? Gravitational force of attraction. First of all, this mass is acted upon by how many number of forces? One force which is towards this direction, because it is always attractive, I said no ma. So due to this mass will experience attraction force in this direction. So this is the first force. And not only this force, this mass even attracted by this mass also. So therefore this will be the second force, F. Both will have the same magnitude and the directions will be different, such that the angle between them will be how much? 30 degrees. 30 degrees, because this total angle is 60 degrees, no? That I am splitting like a 30 and 30. Now the component of this force is act along this direction, right? So what is that component of force? That component of force along this direction is F cos 30 degrees. And due to this will also F cos 30 degrees. Totally will be how much? F cos 30 plus F cos 30. Totally 2F cos 30 root 3 by 2. So 2 cancel out. What will get? Root 3 times of F. This is the resultant force acting on this mass towards the center. Now where does the center of mass will lies? Exactly here. Now that will be actually the center of this circle is same as that of this triangle's center point. So this point, actually this point will have the property. How it will, what is the distance from here to here ma? Because I want to write here r, no? That radius is nothing but what? The center point for this triangle, right or not? So therefore the force I have found, how much it is? Root 3 F. What is the F here? So let me write here root 3 times of what is the F? G m square upon L square. So therefore here what I can write? Root 3 times of G m square divided by the L square. Now that must be equal to m v square divided by what is the r? Radius of the circular path. Radius how to find out? So it is like a center point for this triangle, no ma. So now how we will do? Let us do like this. I would write separately the diagram like this. This is what we have, right? So this center point is like this, no? Now this distance is nothing but L by 2. This distance is nothing but L. Then what about this distance? This whole distance will be nothing but how much? Root L square will be equal to L by 2 whole square plus this total length, and let me call as an x. Okay na? So x square. This total length I would like to call as an x. Okay na? So now from this one what we can write? X square will be equal to L square minus L square by 4. So 3L square divided by 4. So x will be equal to root 3L by 2. This whole distance is how much? Root 3L by 2. But I want to know the distance from here to here only. Okay. Now how it will be? Actually this point, the center point for this triangle, will divide this total distance in the ratio of 1:2. Or you can do this like also L by 2 L. Okay. So now this distance is totally how much ratio? 2:1. So what is going to be the total distance now? I think I am confusing you to little extent. Okay, I will proceed in this way only. So 2:1 ratio, the total distance is root 3L by 2, the ratio it is dividing is 2:1, and so therefore what is going to be total value? Man, this is total value is how much? 3, no? So root 3L divided by 2 times of 3 will be equal to L root 3, and in that it is at twice only, no? So therefore 2 times. Now 2 to get cancelled. How much will get? L by root 3. So this distance is equal to how much? That means radius equal to how much? L upon root 3. Now this root 3, if it comes to numerator, root 3 times of gm square divided by L square equal to root 3 times of mv square upon L. Now root 3 cancel and m cancel out. L, so what we'll get? V will be equal to under root of gm upon L. So this is the speed of the particle. This is the speed of the particle. You're all clear with this point? Any confusion you have? I think this small point you are not getting clearly. So that I understood. So x will be equal to root 3 L by 2. So what we are doing here is, for example, if I have some 100 rupees in my hand. Okay, so if I want to divide into 1:2 ratio, what I will do is, first I will divide 100 divided by the total sum equal to how much? 3 now. Then I will get each value how much? 3 parts are there now, totally how much? 100 by 3. Now this is person A have to get, this is the person B have to get. Then the person A will receive the amount as a 100 by 3 times of 1, which is equal to 100 by 3 rupees. Okay, and person B has to get as a 100 by 3 times of 2. Therefore 200 divided by the 3. This is what amount they will receive. So if 100 rupees has to be split in between the A and B, person A and person B in the ratio of 1:2, then we will proceed like this. What we will do? 100 rupees will divide with the 3 and 100 by 3 into 1 person, 100 by 3 into 2, 1 person. Like this we will split. The same logic I have applied here. What I done? This total distance I found as a root 3 L by 2. This root 3 L by 2 I am splitting into 2:1 ratio. So first I have divided with the 3, then where is that? We have divided with the 3 and then out of that we will get, so root 3 cancel out. So L by 2 root 3. Out of these 2 parts only I want to know. So that I multiply with the 2, I got L by root 3. In that way we found that value. Yes, now you all understood, Amma? Okay, done. So now let us proceed with the next thing. Okay, so this is the problem. The speed of the individual speed of the particle we have found root of gm by L. Okay, na? So hope you are all clear with this one. This logic once again, if you see, then you can apply the same thing to here. Okay, na? Done. Okay, so we will go for the next sum now. Here is the problem number 2. Here is the problem number 2. So the problem 2 is going like this. Chalo. So there is one solid sphere of radius capital R. There is one solid sphere of radius capital R. Okay, na? And its mass is 8m. The mass they have given it as in mass is capital M. The radius is capital R. It's a solid sphere. And there is a one point charged mass is kept at a distance of 2r. So this total distance equal to how much? 2r. And from here to here the distance is how much? R. So this distance outside is how much? R. Okay, now like this it is there. So one solid sphere having the mass m, the radius is r. This is a point charged mass. Okay, so the point charged mass is having the value small m. Now the question is, so when this situation is like this, let us suppose the force of attraction is F1. The force of attraction is how much? F1. Now what they done is, they made one small spherical cavity inside this with the radius of r by 2. The radius of this cavity is how much? R by 2. Now the question is, when this cavity with the radius of r by 2 is made within a solid sphere, now what is the force of attraction between the sphere and the small m is nothing but F2. Now they are asking to find out the ratio of, find the ratio of F2 to F1. I will repeat the question. Look at this one. So the question runs like this. So what is the question mark? This is a solid sphere, it got a radius of r, and there is a one point charged mass that is kept at a distance of 2r from the center of the sphere. Now when the situation is like one complete sphere is there, one point charged mass is there, the force of attraction between them is nothing but F1. Now what they done? They made one small cavity here, and that cavity is having the radius of r by 2. Now in this situation, the force of attraction between them is nothing but F2. Now what is the ratio of F2 to F1? This is what the question. Okay, now we will start doing the sum. First of all, before the doing cavity, what is the force of attraction? The centers, what we said, gravitational force of attraction is always along the centers of the 2 points, right or not? So for this is the center and this is the point charge mass. What is the distance between them? 2r. Therefore what we can write? F1 will be nothing but gmm divided by 2r whole square. So gmm 4r square. This is the force of attraction between the center of the sphere and point charge mass before cavity is made. Now when we make the cavity here, then what we will do is, we want to find out the force F2 now. So for that, how we will proceed is, we will do like this. First of all, this force already we know gmm by 4r square. This is nothing but what? Force of attraction done by complete cavity. From that, if we subtract this amount of force of attraction between the small sphere and this mass which has been kept here, when we make the cavity, what we'll do is, already we done similar problem previously, so where the moment of inertia, if we want to find out for a disk where some small disk is kept out, taken out, then what we have done, the moment of inertia for the whole disk and minus the moment of inertia of this small disk. If we remove, then what we will get? The moment of inertia of the remaining disk we will get. Same logic we will do. What we will do is, let us suppose F1 is the force of attraction between the some complete solid sphere and mass. Okay, force of attraction between complete sphere and mass M. Okay, and let us suppose F prime is nothing but the force of attraction between the small solid sphere having the radius of r by 2 and mass M. Okay, now actually what is the F2 is nothing but the force of attraction with cavity will be nothing but F1, that is nothing but the complete force of attraction minus the force due to small sphere having radius r by 2. This is the logic we want to follow here. Okay, so now it's clear for you. I don't want to make it so complicated by writing symbols and all. So this is the logic we want to follow. So the force of attraction between the solid sphere and the mass with the cavity will be nothing but what? The force of attraction without cavity. What is the force of attraction between them? Without cavity minus the force due to the small sphere having the radius of r by 2. Between these two, now it will have some force of attraction. Now that force of attraction, if we remove, if we subtract from the total force of attraction, here what we found, then we will get the F2 with the cavity. You all understood this logic, no? You all understood this logic? Actually, what is the F1? With cavity plus force due to the smallest sphere will be nothing but what? The force of attraction between the sphere and mass without cavity. F1 is nothing but without cavity, F2 is nothing but with cavity, and F is nothing but the force of attraction between the small sphere having the radius of r by 2 and point charged mass. Okay, na? So now if I want to find out the force due to the small sphere, so now I just want to know what is the mass it will have, correct or not? Then how to find out that mass? We will do like this one. So we will explain like this. The total mass of the sphere is how much? Capital M. And what is its volume? 4 by 3 pi r cube. And what is the volume of this small sphere? 4 by 3 pi r by 2 whole cube. Right, now if you divide these two, 4 by 3 pi, 4 by 3 pi cancel. What I will get? I will get m by 8 only now. So this is nothing but mass of the small sphere. In that way, shall we write directly that formula here? F2. Here I have written with the cavity. So F2 I am writing. Now that will be nothing but F1. F1 value is how much? Gmm divided by 4r square minus the force of attraction between the small solid sphere and small m now. So there G. What is the mass of this small sphere? M by 8. And what is the mass of the particle? Small m. Now what is the distance between the center of this and center of this? The whole distance is 2r. and from that r by 2 I have to subtract. So 2r minus r by 2, totally how much? 3r by 2, and that will substitute back. So 3r by 2 whole square, right? Now let us simplify this one. What we will get? GMM divided by 4r square minus GMM divided by 8 into 9r square, and in the numerator it will go as a 4, right or not? Well, now from this one, 4 ones are 4 twos are. So from this what we'll get? It is 18, it is a 4, no? So if we simplify this relation, 9r square by 4, it is 8 will be there, 4 ones are 4 twos are. So GMM by r square, if you take out the common, what you will get? 1 by 4 minus 1 by 18, right? So from this one let us simplify this thing. So you are all understood this one. Simplification we are going to do now. Now if we simplify this one, we will get it as a GMM by r square times of, so 18 minus 4, 14 divided by 18 into 4, right? So 2 2s are 2 7s are. So totally how much you will get? 7 GMM divided by 36 r square. This is the F2, and here we have F1. We have to divide the both. So F2 by F1. This is what I want to find out now. So F2 by F1 will be nothing but, from both of them, GMM by r square, GMM by r square will be cancelled out. We will get in the numerator 7 by 36 and in the denominator 1 by 4. So that what will get? 7 by 36 into 4 by 1, 4 ones are 4 9s are. So the ratio of F2 to F1 will be nothing but 7 by 9. This is nothing but 7 by 9. So you are all clear with my point? Any confusion? So let me repeat the question in brief what I said. This is a complete solid sphere without any cavity. The force of attraction between them, they call it as an F1. When we make one cavity here, that means this mass is removed, no? Then the force of attraction between them will be nothing but F2. They are asking to find out the F2 to F1 ratio. Well, first thing what I done, I started to note down what is the F1 value, GMM by 4r square. From up to here it's very clear. Now how I have written this formula, that only you have to understand. The force of attraction with the cavity is nothing but the force of attraction without cavity minus the force of attraction between the mass from which, from that cavity we are creating means some mass has been taken out, no? So at that point, if the mass is present, how much force of attraction it will give on the mass m? That amount, if we subtract from the total sphere, that will be nothing but what? The force of attraction between the remaining sphere. If we make cavity here, this is the remaining sphere, no? This wall will be what? Remaining sphere, na? Then between this remaining sphere and the mass m, the force of attraction is nothing but F2, and that is what we have done here. So for that, here I have to find out the mass of this small sphere, no? Mass of the small sphere I have found like this. The total mass is m, so the volume is nothing but 4 by 3 pi r cube, and its volume is nothing but 4 by 3 pi r by 2 whole cube. 4 by 3 cancel out, r cube cancel, we will get m by 8, and that m by 8 alone I have substituted. The distance from here to here is nothing but 3r by 2, and that also we have substituted, we have simplified, and we got the ratio of F2 to F1. Understood everyone? Okay, we will go for next concept now. What is it is, that's the end of this problem, no? Only 2 or 3 models are there, we have finished them. Now we will move on for next concept, acceleration due to gravity. Okay, so there we will just do some formulas, because already derivations we have studied. So just like that we will proceed. Acceleration due to gravity. Acceleration due to gravity. So the Newton's law of gravitation, if we apply for the earth and the small sized mass, we will write it like as a GMM upon r square. Let us suppose this is an earth surface, upon it one small sized mass is kept, and this earth is supposed to have the radius of r now. The distance between them is how much now? R only. So therefore I am writing the force of attraction between them as a gmm by r square. Now that m, if I take to denominator, I will get acceleration of the mass, and that is due to the gravitation now. Therefore we will write f by m as a the acceleration due to gravity, and that will be given by gm upon r square. This is an acceleration due to gravity, small g equal to gm by r square. Okay now, and this can be modified further like this: g by r times of capital M is nothing but mass now. Let us suppose that mass we can find with the formula of rho into v, right? So what is going to be the rho? The rho is nothing but density. So let me write like a rho itself. And what is the volume? 4 by 3 pi r cube. Now r square cancel out. Now we will get the formula 4 by 3 pi r g rho. This is nothing but other formula for acceleration due to gravity. So there are the two formulas for the acceleration due to gravity. One is gm by r square, another one is 4 by 3 pi r g rho. Okay na? Well, so now we will try to understand how does this acceleration due to gravity varies with the different situations. First of all, I don't want to give any kind of derivations. I will give like small derivations only. I will tell for you. Variation of g. Variation of g. This is what we are going to see. Now first thing we will try to understand with the height how this acceleration due to gravity changes. Okay na? So let us suppose this is an earth surface, and here is some small massive particle is kept such that the height from the surface is nothing but h. Now from the center of the earth to this point, what is the total distance? F will be nothing but gmm upon r plus h whole square. Now from here what we can write? Gm upon, shall I write f by m as nothing but acceleration due to gravity at the height h. So what we will write? R plus h whole square. Further gm by r square times of 1 plus h by r whole square. We can write like this now. So now this will be nothing but acceleration due to gravity on the earth's surface. So 1 plus h by r whole square. This is an acceleration due to gravity at the height h. And this can be simplified like this. Let us suppose h is very much less than r, and then h by r will be still very much less than 1. Now if that is the case, this formula can be modified like this: gh equal to g times of 1 plus h by r whole power minus 2. And since h by r is very much less than 1, so actually binomial expansion theorem we have one small formula. What is that? 1 plus x whole power n or minus n, approximately written as 1 minus nx when x is very much less than 1. The same formula I am going to apply here. So now the acceleration due to gravity at the height h will be given by g times of 1 minus 2h upon r. This is the formula. G is equal to g times of 1 minus 2h by r. And I will tell you one thing. If you know the height is less than 100 kilometers, above the earth's surface, if you confirmly know that the information given in the problem having the height which is less than 100 kilometers, then only you apply this formula. Otherwise don't operate to do anything with the formula. Always remember the acceleration due to gravity at the height h is given by the formula gh equal to g divided by 1 plus h by r whole square. Unless you know the height is less than 100 kilometers, don't try to touch this one, because it will have some misconception. What is that? For example, if h equal to r by 2, if I substitute, what I will get? R by 2 na, r cancel, 2 to cancel, 1 minus 1, 0. That means, is it mean that at the height h, which is nothing but r by 2, gh equal to 0? No. The acceleration due to gravity will become 0 at infinitely long distance only, not at the height of h equal to r by 2. This is it will leads you wrong way. This formula will lead you wrong way if you stick on to this formula only. Okay, so try to remember this one. You have to use this formula when you know conformly the height is less than 100 kilometers. Otherwise, don't touch with this formula. go with always this formula only. Or you remember you have only this formula, and very special case only you will have this formula. Okay, na? So remember this thing. This is an important formula. Now the next thing, the acceleration due to gravity variation with the depth. The variation with the height we have seen, and we have to see the variation with the depth. So with the depth, how does this variation will be happen? With depth. So with the depth, we have very simple way of understanding what is that is. We have already one more formula for the acceleration due to gravity. What is that? 4 by 3 pi r 0. And this is for what? The complete radius of r. Let us suppose the particle is kept at the depth d. The particle is kept at the depth d. Now, acceleration due to gravity due to this part only, and this small massive sphere will supposed to have the radius of r minus d only, no? So this particle will experience the force of attraction due to this only, not due to the complete remaining part. Due to this remaining part, it acts as a shell. Due to the shell, the force of attraction inside it will be equal to 0. So therefore, due to this small sphere here at this point, the force of attraction can be, the acceleration due to gravity can be found like this. G at d will be nothing but 4 by 3. For this sphere, what is the radius I told? R minus d, no? So in the place of r, what we have to write? R minus d into 0. So 4 by 3 pi r into 1 minus d by r into g into rho. So therefore what will get? G times of 1 minus d by r. This is the acceleration due to gravity at the depth d. This is the acceleration due to gravity at the height h, and this is the formula for acceleration due to gravity at the depth d, that will be given by the formula g times of 1 minus d bar. But this in this formula there is no further any kind of simplification we can make directly. If we have d equal to r, that means what? At the center of the earth. D equal to r means what? At the center of the earth. If we substitute, what we will get? Gd equal to 0. Therefore, it is correct only. The acceleration due to gravity at the center equal to 0. And when we proceed from this point to the top, acceleration due to gravity continuously increases, and then from there it will be decreases with this formula. Okay, so now if we plot the graph, we will get like this. Now these graphs are important. In case of this gravitation lesson, usually we will get graphs as a question. Even last before year, for past 2-3 years, questions have been asked from this gravitation lesson based on these graphs only. Okay. Now let us understand graphically how does this acceleration due to gravity change. For that, we will plot the graph like this. Here is nothing but r, the distance from the center of the earth. Okay, na? So at the center it equal to 0, no? The acceleration due to gravity is 0 at the center. Now till the radius reach the surface is, that means what? Capital R, acceleration due to gravity is linearly increases. It will be directly proportional to each other. From there it will be decreases like this. That means what? G is inversely proportional to R square, and outside of there G is proportional to R inside the earth, where R is nothing but what? Distance from the center of the earth. Well, that is very simple logic only. Here Gd equal to G times of 1 minus d by r we have written now. Shall we write like this one? G times of r minus d divided by the r. Now you tell me this one. If this is the d, then this will be the r minus d. Now it is nothing but what? Distance from center only, na? This is what called a distance from center only, na? That's what shall we write it as an r. So G by r times of small. From here what we can say? Gd is directly proportional to r only, no? Therefore I got linear relationship. Are all getting my point? At the depth d, this is the r minus d distance. This r minus d distance let me call as a small r. This is nothing but small r. Now in the place of r minus d I am writing small r. Now this expression can be written as what? G by capital R times of small r. From here what we can say? G d is directly proportional to r, where r is nothing but distance from the center to this point, not from the top to this point. From the center to this point, the distance is r. From the top to this point, the distance is d. It is nothing but depth. So that's what we have written here. Understood, everyone? Okay. Now we will go for the variation of the acceleration due to gravity with the latitude. with the latitude how it will be varies. What is the meaning of latitude? If this is an earth surface, let us suppose, and if we have one imaginary line which is separating, like which is representing the equator. Now this is the any point on the earth surface. Now the line joining the center to the point P will make some angle here as a, let me call it as a lambda. Now that lambda is called as a latitude. At any latitude, the acceleration due to gravity will be given by the formula g minus r omega square times of cos square lambda, where lambda is nothing but latitude. Okay. Now at equator, near the equator, lambda will be equal to 0, no? So cos 0, 1. Therefore, what will get at an equator? This value will be g minus r omega square. This is the formula. And near the poles, lambda will be equal to 90 degrees, no? 90 degrees if you means what will get? 0. So what is the g at pole? The acceleration due to gravity at the poles is nothing but maximum g. The acceleration due to gravity at the poles is maximum, acceleration due to gravity at the equator is g minus r omega square. And these are the formulas. So hope you are all clear with this. Now based on these formulas, we are going to do few number of sums now. Okay. Okay, so here is the first sum. The sum is like this. Okay. Here is the first sum. The height at which acceleration due to gravity decreases by 36% of its value on the surface of the earth is the first question. They are asking to find out the height at which acceleration due to gravity decreases by 36% of its value on the earth. This is the question. We have to find the height at which acceleration due to gravity decreases by 36% of its original on the surface of the earth. This is what the question. Well, so decreases by means what? It means at this height, the acceleration due to gravity, if I write like a gh, that must be equal to, from the original, 36% of g is decreasing, no? So therefore I am writing like a minus. From this one, what we can write? 64 upon 100 into g is going to be the formula for gh. Now, do you have any information of the height? No, that only you have to find out actually. Then what is the formula I asked to use? If you don't have any information about the height, then you have to go with the formula g upon 1 plus h by r whole square. And now that will be equal to, according to the given problem, g into 64 divided by the 100. Now g can cancel out. And 1 plus h by r whole square will be nothing but 100 by 64. Okay, now 1 plus h by r equal to, this value will be how much? 10 by 8. Now I want to find out h, no? So h by r will be equal to 10 by 8 minus 1. So 2 by 8, so 1 by 4. So what's the height now? R upon 4. What's the radius of the earth? 6,400 kilometers divided by the 4. So therefore what will get? 4 1s are 4, 24, 4 8s are 24, 4 6s are 24, okay, 1600 kilometers. This is the height at which acceleration due to gravity will be decreases by 36%. Since I told it is decreases by 36%, I have written gh equal to g minus 36 by 100 of g, and that's I have written as 64 by 100. And further simplification we have done. We have calculated the value of h as a 1600 kilometers. Okay, right. Now let us go with the next sum. Next sum is like this. So suppose I will write on the board. Okay. Suppose this is the problem number 2. Suppose the earth increases its speed of rotation. Then at what new time period will the weight of a body on equator become 0? Okay, they ask to take G value as a 10 meter per second square and R value as a 6400 kilometers. Okay, let me repeat the question again. Suppose Earth increases the speed of the rotation. If the speed of rotation is increasing, at what new time period? At what new time period will the weight of a body at the equator becomes 0. So at the equator the weight has to become 0. So generally mass will never be, weight means what? M into G only na. So it has to become 0 means mass will never become 0. So only there is a chance for the acceleration gravity, right? Mass will never become 0. Only acceleration due to gravity can be become 0. Then what is the value of G at equator? We have studied just now the variation of G at a latitude, that will be given by G minus R omega square times of cos square delta, and near the equator lambda value will be 0. So G lambda will be equal to G minus R omega square, and at that equator it has to become 0 no. So G minus R omega square equal to 0. From this one what we can write? G equal to R omega square, and therefore omega equal to under root of G by R, or in other words T equal to 2 pi root of R by G, and this is the standard value. This value will be 84 minutes, or in other words it is a 60 minutes plus 14 minutes no. I mean 60 plus 14 24, sorry, 60 plus 24, therefore it can be written as a 1.4 hours. So this is nothing but time period of revolution. That means what? Now what is our time period of revolution for Earth? 24 hours. So if our Earth has a 1 day in just 1.4 hours, then our weight near the equator will be 0. We will be free fall near the equator. Okay, that is the meaning of this topic. This is a very standard value. Even if you substitute that things, you will get the same thing. Okay, na? So you are all clear with this sum? Done. Okay, we will go for the next sum now. The next sum is like this. I will read the problem and then I will write the information. The ratio of radii of Earth to other planet is 2/3, and the ratio of their mass densities is 4/5. If an astronaut can jump to the maximum height of 1.5 meters on the Earth, with the same effort, the maximum height he can jump on the planet is. Okay, so here we have given with the two information. This is the problem number 3. One is the Earth, another one is the imaginary planet. So for the Earth to this planet, the ratio of radii is nothing but, that means what? Re upon Rp, ratio of radii of Earth to other planet. Earth to other planet is how much? 2/3. And the mass density ratio, that means what? Rho E upon rho P will be how much? 4/5. They told it is a 4/5. Now, if astronaut can able to jump to the maximum height of 1.5 meter on the Earth, so to the maximum height of 1.5 meter, if he can able to jump, to the what height will the person on the planet could able to jump? This is what the question. And we know very well the maximum height that one body can be traveled to the some height will be nothing but what? U square by 2g only na, because at the maximum height generally v will be 0, and therefore v square minus e square equal to minus 2gh. So therefore v square equal to 0, we will get h max equal to u square by 2g. Therefore what we can write? H max on the Earth multiplied by the g on the Earth must be equal to h max on the planet multiplied by g on the planet. Understood? Because h is inversely proportional to e. With the same effort they told na, what is the meaning of that? For this person who is jumping from the Earth will have the same initial velocity and the planet also. With the same effort he is able to jump. So therefore u will be the same. But g will be differs from this Earth to this planet. So therefore we can write these two are inversely proportional to each other. So hg will be equal to hpgp. Okay na? So now we want to find out this hp value. This is what our question. Now what we have to do? He times of g to gp ratio I want to find out. With that problem will be simple. Okay. Okay. Now how we will proceed? So since we know very well the acceleration due to gravity in terms of density is given by the formula pi uh, 4 by 3 pi r g rho. 4 by 3 pi r g rho. Now for the earth and for the planet, let me write like a differently. What will get 4 by 3 pi r e g rho e divided by 4 by 3 pi r p g rho p. Now 4 by 3 pi 4 by 3 pi g cancel out. What will get ma re to rp ratio multiplied by rho e to rho p ratio. These values are how much? 2 by 3 and 4 by 5 no. So if we simplify this relation, what will get? He times of Ge to Gb value is how much? This product ratio no? So therefore what will get? A divided by 15, which is equal to height on the planet. What is the height on the earth surface? He can able to jump 1.5 meters. So therefore 1.5 divided by the 15 into 8 will be nothing but height of the person, I mean height to which he could able to jump on the planet. Okay, now this will be equal to how much? 0.8 meters. So on the earth surface, if he can able to jump up to 1.5 meter, here on this planet he can able to jump up to just 0.8 meters, less than that value, because acceleration due to gravity is more for this planet and it will be less for the earth. Compare in between these two, if we compare, we will get like this. Okay, so this is how we can understand this. Okay, so let us proceed with next sum. Okay, instead of doing the next term, better I will start with one concept called gravitational field intensity. Gravitational field. First of all, let us know what is the gravitational field and then I will tell you field intensity. Actually, the meaning of field is nothing but the space surrounded by any mass in which other mass will experience, another mass will experience some kind of force of attraction. So if here I have a capital M mass and let us suppose it could able to attract up to this region. So in this region, if any mass comes, what will happen? It will experience a force of attraction towards it, right or not? Now this region is called as a gravitational field and this field will have some power. That power is nothing but field intensity. So gravitational field intensity I would like to find out now. So it is very simple case, like already for your plus 2 you have studied electric field intensity. How we will do electric field intensity? We will write like the force experienced by unit positive test charge, like that. Here also gravitational field intensity is given by the formula force experienced by unit mass. The force experienced by unit mass. For example, if this is the capital M, now I will write one by one. First formula, the field intensity due to point sized mass. Now I will give the formulas due to point sized mass. So let us suppose this is the point sized mass with the mass M, and here I have kept a small m mass. Let us suppose the distance between them is r. Okay, now at this point I would like to find out what is the field intensity. What is the force of attraction between them? F equal to gmm upon r square. Now if I take that small mass to the denominator, I will get what? Gravitational field intensity due to the mass, that will be given by gm upon r square. And since it is an attractive force in nature, the gravitational field intensity must be represented with the negative sign. E will be equal to minus gm by r square. You have to represent the gravitational field intensity specifically by sign convention of negative sign. In some books they have given without negative sign. Very few books they have given sign of negative. But you remember, whatever the book if you see, you should have keep in your mind that gravitational field intensity must be represented with a negative sign. Keep in your mind that important point. Okay, so E will be equal to minus Gm by r square. So this is the field intensity due to the point charge mass. If we plot the graph where distance versus gravitational field intensity, you can find both are inversely proportional to each other. No, so this will be that graph. Okay, and the next set of formulas I will write. Hereafter we will not give any derivations. So this is the field due to the point charge mass. The next due to the spherical shell. So due to the spherical shell, let us suppose this is a massive spherical shell. Okay, and it got a radius of capital R, let us suppose. Okay, then the gravitational field intensity will be equal to minus Gm upon small r square when r is greater than capital R. That means what? At outside point, this will be the field intensity, and this will be equal to minus Gm upon capital R square when r equal to capital R. That means what? On the surface, and the value will be 0 when r is inside. That means what? Here the field intensity is 0. Okay, na? So due to the spherical shell, the gravitational field intensity is given by the formula minus Gm upon small r square minus Gm by capital R square at a upon the surface, and it will be 0 inside it. And let us draw. And for this, what will be the graph? I'm sorry, here it is a negative quantity. No, just I have to reverse it. I'm sorry for it. It will be like this. Just a mirror image of the previous one. Actually, we will draw like this. No, that mirror image will be like this. Like this, we will draw. Okay, and for this one, we will have the plot like this. Upon the surface only, we will have field intensity. Then it will decreases like this. Now this will be the graph for it. This is the graph for E versus R. This is the radius R. Okay. This is the graph for it. Okay, and the next one, the field intensity due to the solid sphere. Remember, these graphs are very, very important. So the next one, due to solid sphere. What is the field intensity? And for that also we will draw the diagram. So this is a solid sphere. It has a mass of m, and let us suppose the radius it got is capital R. Then the field intensity at the outside point is given by Gm upon r square, where r is less than capital R, and it will be equal to Gm upon capital R square when r equal to capital R, just like upon the surface and outside point. And inside it, it can be written as Gm upon r cube into small r. So when r is less than r. Now you see this one. If you substitute r equal to capital R, again you will get the same formula. That means what? Here r is nothing but from the center towards the surface. Okay, na? So the distance from the center to the any point inside the sphere. So that point, if it reaches to the top, no, then it will becomes what? Field intensity at the center. I mean on the surface of the sphere. And for this, how will be the graph? This will be the graph, ma. This is the r versus E, and till the surface reaches, the field intensity is directly proportional to each other. So it will be like this. It will be like this, directly proportional to each other. No, so it's a straight line, and from the surface it will be decreases. From the surface it will be decreases. Okay, so this is how we can draw the diagram. I mean the representation for the gravitational field intensity versus distance for the different orientations. Now finally let us draw the gravitational field intensity for the Earth. Earth is nothing but solid sphere. So the graph what we have drawn just now for the solid sphere and the formulas, that will be same for the Earth also. So the gravitational field intensity due to Earth, if we want to write the formulas, then simple. The gravitational field intensity at the outside point is minus Gm upon r square for r greater than capital R, and upon the surface minus Gm upon capital R square and r equal to capital, and minus Gm upon r cube into small r for r less than capital R. So like this we'll have, and this was the one of the old APMT question ma. They just given 4 graphs. Among them, which one is correctly representing the variation of the gravitational field intensity due to the Earth. So they have asked 4 graphs. Among them, this is the correct one. Okay, you are all clear with this one. So this is what. So in this session, what and all we learned? We learned about what is the Newton's law of gravitation, the properties of gravitational force of attraction, and then we understood 2-3 problems based on that context, and then acceleration due to gravity, the variation of acceleration due to gravity. We done 2-3 problems on that, and finally we have encountered what is the meaning of gravitational field intensity, and I have given some formulas for gravitational field intensity due to the different orientations. And the next session we will do with the problems on the gravitational field intensity. Based on this concept, how does the problems will be asked, that and all we will do. With that, we will proceed in the next chapter. Okay, na?